Morning, everybody. Today is day 24 of Math 133. We're going to talk about the Chapter 10 review on page 526 in your course pack. Don't forget to do the lecture notes. Um, and so last time, I had asked you guys what you wanted to do about April 16th because I will not be able to teach the evening class next week on Thursday. Thank you for filling out the survey. The results, 88%. Everybody wants to do the morning Zoom like normal. I'll record that session and then the evening students will need to watch that. So, you guys are the morning students, so that doesn't affect you guys at all. Everything's just going to stay the same. So, and this is not a this 88%, that's not p hat, that's the population proportion, right? That's everybody. So we didn't have to do a sample or anything. So, um, when you have a huge population, like if this class was, 1,000 people, then okay, well, maybe I can't measure everyone, but yeah, here, if you can measure the whole population, just measure the whole population, right? So in other words, we are leaving everything the same. So just keep doing what you're doing, come to class. We'll cover the Chapter 11 project next week on Thursday. Okay. Um, I also sent in Remind, I sent you another survey on where you plan on taking the final exam. And I just sent you moments ago information about the final exam, and I'll drop that in the chat for you as well for the final exam proctoring. This is very similar to what you saw for the midterm, so there's nothing really new in here. Uh, you still have two choices. You can join me on Zoom on Thursday, April 30th, from 9 to noon or 6 to 9 p.m. Or you can take it at the testing center Tuesday, Wednesday, Thursday, or Friday during the final exam week. Um, Either of those is fine. So, uh, there is one minor difference with what you're allowed to have at the exam. You're still allowed to have your entire exam notes packet, and you're allowed to have two sheets, front and back, of an 8.5 by 11 piece of paper with whatever you want on it. And you're also allowed to have your Chapter 11 flowcharts. There are three of them. We haven't started doing those yet, but when they get assigned, make sure you fill those out because you'll be able to have them at the final exam. So super helpful. Um, so you're not allowed to have your course pack in front of you. You're not allowed to have any of your assignments. Like today, we're going to cover the Chapter 10 review worksheet. You're not allowed to have that with you. Um, you're allowed to, write whatever you want on your 8.5 by 11 piece of paper so you can copy things from that. Like if there's a question that we covered today where you're like, oh, that was really difficult. I want to make sure I know how to do that on the final. You're allowed to write that on your 8.5 by 11, but you're not allowed to have your notes in front of you. You're not allowed to have previous assignments or previous tests. You're not allowed to have the midterm in front of you. Okay. You can use the same 8.5 by 11 piece of paper that you used for the midterm and just, make a second one. That's fine. Okay. Um, Final exam covers chapters 1 through 11. The midterm was 1 through 6. You will still see information on the final four chapters 1 through 6 there. But you'll see more chapters 7 through 11 things. Okay. Um, the sample final exam, which we will be covering uh, for 2 days in our Zoom class. You still have to turn that in. That is different from the final exam. The sample final exam counts as a worksheet, so it counts toward the worksheet points. Okay. The final exam is 12 pages long, so a little bit longer than the midterm. What else? What else? What else? If you're taking it with me on Zoom, I need to be able to see your screen so I can tell that you're not on Google, you're not looking up things you're not supposed to, and I need to be able to see you so that specifically your workspace in front of you, so I can tell that you don't have, uh, documents you're not allowed to have. You're not allowed to have your course back, right? I mentioned that a second ago. I need to be able to see your workspace so I can tell that, you're not looking things up on your phone. You don't have, you just have your 8.5 by 11 papers in front of you. Okay. I don't have to see your face. I just have to be able to see what is on your workspace. Okay. Um, um, yeah. I mean, this is all the same stuff we did at the midterm, right? So nothing huge, nothing crazy different. If you're taking it at the testing center, location is here in the Burt Walker building. So yeah, so there's that. So take a look over that. There we go. And of course, if you have questions, always uh, ask. I want to make sure, I'm setting you guys up for success. All right. Right. So today, chapter 10 review, page 526, and we're going to be talking about hypothesis testing. Okay. So one of the two superpowers that we get out of the central limit theorem is confidence intervals, which we talked about in chapter 9. Okay. And the other superpower is hypothesis testing. Okay. Since the central limit theorem says that the distribution shape of the sample mean or the sample proportion is normal, that allows us to use the normal curve, which we could do a lot of things with. Okay. So we're doing hypothesis testing. We are claiming that something is true. So, like, we want to say, like, this medicine is more effective than the old medicine. Or we want to say that this, you know, uh, this thing this car is safer. You there's less fatal accidents, right? Um, so anyway, so when we're doing that, we're testing that against some alpha, right? And we uh, calculate a p-value and compare that, right? All of this stuff is on page 262, right? That's for proportions, page 262, hypothesis testing for single proportions, or page 263, hypothesis testing for single means. Just like with confidence intervals, you kind of get bonus material. You get 2 for 1. It's kind of like 2 classes in one. You get information about how to do this for proportions and also means. So because of that, you have to pay attention to whether you're looking at proportions or means. Okay, the differences are very slight, right? You might see, so the formula is slightly different, Z versus T, right? Checking normal is slightly different, okay? But as long as you pay attention to that, you're fine. Okay. Um, all right. So, uh, study A, B, C, and D has the lowest chance of a type 1 error. The probability of a type 1 error is called alpha. Okay. And you want alpha to be small because we don't want to make errors, right? But sometimes a type 1 error is terrible. And sometimes a type 2 error is worse. Okay. And we'll see that as we go through this review and some of the other review worksheets that we're going to do. Um, so sometimes they both suck. Sometimes making either type of error is going to have consequences. Okay. Um, but if type 1 errors are really bad, you want to make your alpha really small. The probability of a type 2 error is not alpha, it is called beta, which we're not going to calculate. It is related to the alpha, but it's also related to your sample size. So for question C, assume that all of the sample sizes are the same. Okay. Otherwise, you can't answer this question. We said that for our chapter 10 project, since you had different counts of M&Ms and Skittles, that you couldn't answer it. But if you can't answer it if the sample size is the same. Okay. Um, so I'm not going to go super deep into it, but so when looking at our green curve here, this green curve is a normal curve, okay? And if we were doing a right tail test, we would shade in alpha, or we would shade in that p-value, right? So we remember doing that on like our when we're doing a right tail test, you would shade in this area over here, right? That's this p-value is what you're going to compare to your alpha, okay? This green curve is the population normal curve. Okay. Sorry, it's not the population. It's the distribution of the sample means, but think of it like the population. Okay. So, um, this purple curve, though, we don't draw two curves, right? We draw one and then we shade. So where is this one coming from? The idea with hypothesis testing is if you do this sample and you see something weird, you see something that uh, is unlikely, right? Like, let's say that this green curve is like a placebo medicine. Placebo doesn't do anything. So, what percent of people are going to, get sick and die from this disease? If they don't get any medicine or if they just take a placebo, they're going to be on this green curve right here. If they take the medicine, that's going to increase their chances of survival. It should. You want it to, right? If your medicine is good, if your medicine is effective, it's going to shift their chances of survival to the right. And that's what this purple curve is showing. Okay. And wherever your line for alpha is, if you draw that same line on the purple curve and shade to the left, that's beta. That's the probability of making a type 2 error. Okay. And the further you shift this purple curve to the right, the smaller your beta will get because alpha is not moving. This red area is going to stay where it is. But if you keep shifting this purple curve farther and farther to the right, then your beta is going to get smaller and smaller. Okay. So if you do move your alpha, that shifts the beta as well. So basically, what I'm getting at is beta is affected by the alpha, and it's also affected by how far this purple curve is over to the right. Okay. And the bigger your sample size, the more accurate your results will be. And so you'll be able to detect things better. And so that's what I mean by shifting this purple curve. Okay. The other thing is this purple curve, if it was narrower, so if it was less spread out, then it would also have a smaller beta. And that is also affected by the sample size. Okay. All right. That's as far as I'm going to get into beta. If none of that made any sense to you, don't worry about it. Okay. All you need to know is if you have a large alpha, you'll have a large chance of a type 1 error. And as long as your sample sizes are the same, then a large alpha means a small beta. Small alpha means a large beta. Okay. That's all we're really going to say on that. All right. We're going to move on though. Um, so type 1 errors and type 2 errors are sometimes also called false positives or false negatives. And I always have to look it up because I never remember which one is which. Um, so, question number 3 down here. In June 2020, early days of the COVID pandemic, Johns Hopkins researchers released a study that in the US there was about a 38% false negative rate for COVID tests. False negative. That's that's a terrible error rate. 38% of the time your test is wrong. So, what does it mean for COVID-19 test to give a false negative result? What do you guys think? Put it in the chat. What do you think the answer is for answer 3A? What does it mean for a COVID test to give a false negative? Well, if you're not sure, what does it mean for a COVID test or any like test to give you a negative result? If you are doing a COVID test and you get a negative result, does that mean you have COVID or not? A negative result on a COVID test means, what does that mean? So, uh, false. So a negative result. No, you're fine, Rachel. Yeah. Um, so a negative result on your test means the test is telling you you don't have COVID. Yeah, Rachel, yeah, you got, yeah, it's the opposite. Yeah. So what that means is a person, uh, so a person tests negative, meaning the test tells them that they're fine. But that's false. That's wrong. If it's a false negative, then that means that the test is saying, nope, you're good. You don't have COVID, but they actually do. So the person has COVID, a person with COVID-19 tests negative, meaning the test tells them they're fine, but they actually have COVID. They actually are sick. Okay. A false positive would mean that the test says that they're positive. It's the test says you have COVID, but it's false, meaning no, you're actually fine. Okay. So a false negative would mean the result was negative. The result says you do not have COVID. That's what negative means. But you actually do. Okay. Why is that a problem? Why is a false negative result a problem? If I have COVID-19, right? And that was the problem with COVID-19 is you never knew if you had it or not, right? So you do the test and the test says you're fine. Why is that a problem? It's because, well, you're taking that test because you want to go do something, right? Like maybe you're planning on going on a trip or you're going to a concert or you're going out with some friends and so you do that test to see if you're okay and the test says you are okay. Well, then what are you going to do? You're going to go to the concert and problem is you have COVID. You don't know it. You have COVID. So you are correct, Kelly. You're going to end up spreading that disease. Will spread the disease to others, right? So that's not good. Okay. You end up spreading it to people. And, you know, a lot of people who had COVID, they were able to get over it, but there were some people with like immune compromised systems or other conditions, especially the elderly, where they couldn't get over it and ended up passing away. And that was terrible, right? So In this case, this is a type 2 error. A type 2 error is where uh, you you don't know it, but you are sick. H0, the null hypothesis is that you're fine, but that's false. You're sick, but you do not reject the null. Okay, that's a type 2 error. So in this case, a type 2 error is terrible. Okay. Now, what about a type 1 error? A type 1 error is, you've got plans, you're going to go to this concert, and you take your COVID test, and it says that you have COVID. You actually don't, but it says you have COVID. Well, that sucks. What's going to happen then? Well, you're going to quarantine. You're going to stay home. The test said you have COVID, so you're going to cancel your plans. Maybe you lose out on the money for the concert ticket. I mean, that's not good, but nobody's dying, right? False positive, you quarantine for 10 days or 5 days or whatever the CDC says at that time. Um, but that's not as bad as a type 2 error where you are actively spreading the disease and don't know it. Okay. So sometimes a type 2 error is worse. Okay. Okay. Anyway, let's move on to the next page, which is page 527. All right. Manufacturer is designing a new jet engine part that is critical for keeping the engine going and the plane up in the air. Manufacturer is testing this part for strength, comparing it to the older traditional model part that they used to use. If the new part is stronger than the old one, then they will install it in their new air jet engines. Okay. Uh, Describe the types of possible outcomes in the grid below. Be sure to use words for reality and decision. Okay. So our null hypothesis is that the new part is not stronger. So the null hypothesis is always going to be that, everything's the same. The new part and the old part, they're the same. Okay. Um, so that would mean that the opposite would be that the alternative hypothesis, the new part is stronger. Yes? Great. Now, we don't actually know if the new part is stronger or not. You can't test the entire population. How would you test if the new part is stronger? Well, you have to figure out how much weight it can hold, right? So you take your part and you bend it and you keep bending and you keep putting more and more weight on and more weight until it breaks, right? And that lets you tell how strong it was. Okay. So maybe the new part can hold 1,000 pounds and the old part can only hold like 500. Well, so you want to find the average, right? Because some parts are going to be a little bit stronger than others, right? Maybe this one holds 1,001, maybe this one holds 999. Um, so you're looking for the average strength. So you can't test the entire population because if you did that, you'd have to bend and test and break every single part you produce, so they'd all be broken. You can't use any of them, right? So what you do is you take a random sample of maybe like 100 or 200 of the parts. You take those and you bend and break those and figure out what's the average weight that your sample holds. And then the rest of them that you didn't test, that's the rest of your population. Those are the ones you're actually going to put into planes, right? So anyway, so you don't actually know if the population is stronger or not because you didn't test any of those. You only tested the sample. So there's a chance that the random sample that you picked, you just randomly picked some of the defective parts, and so or some of the really strong parts you don't really know. So there's a chance that you make an error, right? A type 1 error or a type 2 error. So you don't know the actual situation. You could never know the actual situation because you could never test the entire population. But uh, pretend that, you could, pretend you were God and you were able to look into the situation. You knew that the actual situation is that the new part is not stronger. That would mean that the null hypothesis is true. Um, Or the null hypothesis is false. That means the new part is stronger. Yes? Now, you can't know which of these is true, but you can still make a decision based on what your sample says. Okay? So if you do not reject the null, then that means that you believe the new part is not stronger. And if that's the case, then you're not going to put that in the planes, right? So you will not install it. Okay. If you reject the null, then that means the new part is stronger. You believe that the new part is stronger, so then you will use those parts, right? You will install the new ones. Okay. And I had mentioned before, researchers or statisticians or whoever, you usually want to reject the null. You want to use these new parts, okay? Because they're stronger and maybe they're cheaper to make, right? Like why are we testing these? Why did we switch? Because we had an old part that worked, right? You had a traditional part that you used to use, and now we're switching to this other part. Maybe it's cheaper to make, okay? Um, so you need to make sure though that it's still strong enough to do the job, right? So, all right, so let's say that the true situation, which you don't actually know, but the true situation is that the new part is not stronger and you end up deciding not to put them in the planes. Is that correct or is that an error? New part is not stronger and not installed, right? Yep, you guys got it. That is correct. Was not installed. New part was not stronger and was not installed. You just keep using the old parts, the traditional parts that you've been using. Okay, great. Now that's correct, but that doesn't help your company because hey, we were going to make all these parts and they were going to be cheaper to make, but our testing showed that we can't use those. So, uh, even though we made the correct decision, that's still kind of a bummer, right? But that's not as bad as if we made an error. So if the new part is not stronger, but is installed, is that correct or is that an error? That's an error. Now, which type is it? Is it a type 1 error or a type 2 error? I can never remember. I always have to look it up. So, yeah, you guys got it. Kelly says it's a type 1 error. You are right. Type 1. Okay. All right, so let's go over here now. Let's pretend instead that the new parts are stronger. We don't know that. Like, you we'd have to test every part, but in reality, the actual situation is that the new part is stronger, and we decide that we're not going to put them in. New part is stronger, but will not be installed. That's an error, yes. Yep, Kelly says that's a type 2 error, and you are correct. I don't know why we use Roman numerals for the types. You can just write 1 and 2, but they use Roman numerals. That just a fun thing, I guess. Okay, so then the other option is new part is stronger and was installed. All right. So the new parts are stronger than the old ones, and we do end up installing those. Is that correct or an error? Yes. Kelly says that is correct. Good. Okay. And that's what we want because that means that, oh, these new parts are great. Let's use them. And so we end up producing them and saves our company some money, right? So good. Which situation in this case is worse, type 1 or type 2? Rachel says type 1. Why is that one worse? Yeah, type 1 is the new part is not stronger. You are putting weak, cheap parts in your plane. You're installing those in there, and it says that this is a new jet engine part that is critical for keeping the engine going and the plane in the air. So you're going to end up with more crashes, right? That's terrible. More plane crashes. Okay. This is not good. Okay. Now, a type 2 error is that the parts were good, they were stronger, you didn't know it, and you ended up not using them. Well, what's the problem there? The problem there is, okay, well, you didn't end up getting to save that money for your company, right? So, yeah, so I mean, money is important, but you're not killing people in plane crashes. Type 1 is worse, okay? Now, we saw a second ago with COVID where type 2 was worse because you were out spreading the disease. Here, type 1 is worse, okay? There are some times where type 1 sucks, and there's sometimes where type 2 sucks. And it's important when you are doing this hypothesis testing to decide to set your alpha appropriately, okay? Because if type 1 errors are worse, the probability of making a type 1 error is alpha. In this case, I need my alpha to be very small, maybe 1% instead of 5%, maybe even less. Maybe I need to look at like 0.5% or even smaller. Okay. Um, I mean, you can't make it zero because if you do that, then you're never going to reject the null. Okay. You need your p-value to be smaller than alpha in order to reject the null and you know end up uh, in this correct box over here. Um, you need your alpha to not be zero, but the smaller you make it, the less chance you have of making a type 2 error. Okay. Now, if your type 2 error is worse, then you need to make sure you're setting your alpha reasonably large, like maybe 10%. Okay. Or I guess you could go higher, but because you don't want your beta to be too big. Okay. Um, now the other thing I'll mention is so I said like the researchers that they want to end up in this box. Okay. This is where they want to be. They want to reject the null. Just because you want that doesn't mean you can set your alpha or change your experiment midway through so that you end up rejecting the null. Because if you reject the null and the new part is not stronger, that puts you in this box. Okay. So you can't change your experiment halfway through. You can't adjust your alpha just because you're like, we were so close to rejecting the null. Let's just let's just change our alpha instead of saying it was 5%, let's make it 4.5. Okay. No, you can't do that. Okay. All right. Anyway, um, We'll skip through some of this stuff. Um, we'll come back to that. Question number 6. Um, Conventional wisdom says that the average movie length is 2 hours, but you think that's not right. Um, Test your claims. You gather a random sample of 25 movies from IMDb, find their average length is this, standard deviation is this. Verify the requirements to conduct a hypothesis test or met. So, did you do a random sample, independent sample, and normal, right? All right. Test your claim at a 1% significance level, showing all works, steps, and graph. There are 6 steps. You can find them on page 262 and 263. Now, page 262 is for proportions. Page 263 is for means. Are we looking at a percent or a mean here? We are looking at average movie length. So that's a mean. Page 263. Yes, Kelly says that's mean. So page 263. Okay. Um, so you're gonna write out your requirements. Uh, so what's your H0, right? You're gonna write out what's your alpha. You're gonna write out your formula. T0 equals blah, 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 blah. You're going to draw your T curve, which looks very similar to a normal curve, and you're going to shade one part or the other, okay? Calculate your p-value. You're going to compare your p-value to your alpha, decide if you're going to reject the null or not, and then step 6, you write out your conclusion, okay? The conclusion should be a sentence. It's the result that you would tell whoever you're, doing this analysis for, okay? You're not going to give them this normal curve picture and this formula and all this craziness unless they ask for it. You're going to tell them whether there's sufficient evidence or not to support the claim. You're going to tell them, yep, the claim is good, or no, it's not. All right. And all 6 of those steps, page 263. Lastly, page 529. In 2018, an article for CNN stated that less than a third of Americans own a gun. Researcher for the Pew Research Center decided to research this again in 2024. So 6 years later, they want to look at it again. They conducted a survey of this many random Americans, found that 32% reported owning a gun. So don't forget that p hat is x over n, which means if you multiply both sides by n, you get that n times p hat equals x. Okay. State the null and alternative hypotheses, provide the conditions. So this one you need to do random, independent, normal. Okay. Since we are looking at percentage this time, so what percent of Americans own a gun? 32%. We're looking at proportions. This is page 262. Okay. But still very similar 6 steps. Really, the only thing that changes is the StatCrunch buttons will click and the formula, right? That's really the only thing that changes. Well, I mean, you also change how you write out your hypotheses, right? You're going to write the null hypothesis is p equals versus if you're doing means, it's mu equals, right? The population mean, the symbol we use for that is mu. The population proportion is p, okay? You're always going to use either p equals or mu equals. You would never write p hat equals, okay, because p hat is your sample proportion, and you don't need to test that. You can do your sample and get exactly what p hat is. The whole point of doing a sample is we don't know p and we can't know p. We can get close to it. The whole point of doing a sample with means is I can calculate x bar, so it shouldn't be x bar equals. We're writing out what mu is. Okay. All right. Anyway, that's all the hints for now. Let's jump back to page 526.